Jai Hind. So today we will going to discuss the subject theory of automata and formal language, and the subject code is KCS 402. In the previous lecture we have discussed push down automata and we have construct PDA. Okay, in this lecture we continue the PDA, okay, and construct some more PDA corresponding to the language. Okay, in the previous lecture we have discussed that corresponding to one that regular language will be accepted by finite automata. Okay, and if we add memory or stack element to the finite automata, then it will become the PDA. We have seen the graphical representation of PDA and PDA tuples, right? And we have seen language acceptance. So PDA accept the language by two way: language acceptance by final state and language acceptance by empty stack. So let's construct some more PDA for the language. Okay. So here a raised to power n, b raised to power m, and c raised to power n plus n. So what it means that number of a plus number of b equal to number of c. So this is the language and we construct the PDA corresponding to that language. Okay. So start constructing the PDA for corresponding to the language. So how we construct the PDA? So let's take some sample example and let's see how PDA stack will implement this thing. So suppose A, B and C. Okay. First we push all A and B, then corresponding to C we popped out B and A. Okay. Now suppose this is my stack. Okay, input is A, top of the stack is Z node, we push A. Input is A, top of the stack is A, we push A. Input is B, top of the stack is A, so we push B. Okay. Now corresponding to C we pop all A and B. So input is C, top of the stack is B, so we pop this B. This is the top of the stack. Okay. Now top of the stack is this one. Now input is C, top of the stack is A, we pop. Next this will become the top of the stack. Okay. Input is C, top of the stack is A, we pop A. Now all A and B are over corresponding to C. It means that number of A and B equal to number of C. So let's construct the PDA corresponding to the language. Okay. So there is state Q node. Okay. When input is A, top of the stack is Z node, we push A Z node. Okay. When input is A, top of the stack is A, we push A. Okay. When input is B, top of the stack is A, we push B A. When input is B, top of the stack is B, we push B. Now all A and B will be pushed. Okay. Now when input is C, top of the stack is A, we pop A, or when input is C, if top of the stack is B, we pop B. So these are the pop operation. These are the pop operation and these are the push operation. This is also pop operation. Now I am state at Q1. Now when input is B, Okay, sorry, not B, because all A and B are over. Input is C, top of the stack is A, all A will be over. Okay, input is C, top of the stack is B, all will be B will be over. Okay, now corresponding to this A, B, all corresponding to this C, all A and B will be over. Okay, now string is over, and in the last input is epsilon, top of the stack is gen node. We keep gen node as it is. Okay, and we reach at the final state. We will reach at the final state. So this is the language acceptance by final state. This is the final automata corresponding to the language A raised to power n, B raised to power m, C raised to power n plus m. Okay. Next, see the next example, that A raised to power n, B raised to power n, and C raised to power n, D raised to power m will be equal. How we will do that? Suppose there is string W, A, and C, D. This is the language corresponding to A raised to power 1, B raised to power 1, C raised to power 2, D raised to power 2. This is the language corresponding to the given language. Just see the sample example. So there is stack gen node, this is the input, this is the stack. Now top of the stack is gen node, we push A. We push A. Corresponding to B, when top of the stack is A, we pop A. It means all A and B will be over. Now C came into the picture. Now top of the stack is gen node, input is C, we push C. Now input is C, next input is C, top of the stack is C, we push C again. Okay. Now input is D, top of the stack is C, we pop C. Input is D, top of the stack is C, we pop C. Okay. Now string is over, it means string is accepted or language is accepted. We construct the PDA based on that. So construct the PDA for that. So emit state Q node, input is A, top of the stack is gen node, push A gen node, input is A, top of the stack is A, push A. Okay. Now all A will be pushed. Now input is B, top of the stack is A, we pop A. Okay, and we keep on popping A corresponding to input B. Input is B, top of the stack is A, keep on popping A. Now all A and B will be over. Now C will come into the picture, that input is C, top of the stack is gen node, we push C gen node, input is C, top of the stack is C, and we push C. Okay. Now D is the input, top of the stack is C, we keep on popping C. Okay, and I will reach at state Q2. Now input is D, top of the stack is C, we keep on popping C. Okay, now all C and D will be over. Input is epsilon, top of the stack is gen node, we keep gen node as it is, and I will reach at state Q, final state. So this is the PDA corresponding to the language A raised to power n, B raised to power n, C raised to power m, and D raised to power m. Okay. So next is the next language and construct the PDA corresponding to that. Now the language is A raised to power n, B raised to power m and c, D raised to power n. So how we will do this with the help of stack? So let's see. When A will came, we keep on pushing A. When B will came, we keep on pushing B. When C came, corresponding to 1C, we pop out 1B. Now corresponding to all C, all B will be popped out. Now A remains into the stack. Now corresponding to D, we pop out B. So corresponding to all D, we popped out all D. If stack will be empty or last stack symbol will be Z node, then language will be accepted. So this is how we construct the PDA for the language. Okay. So let's see how we will construct the PDA for that. Okay. Now I am at state Q node. When input is A, top of the stack is when input is A, top of the stack is Z node, we keep on pushing A Z node. Input is A, top of the stack is A, we push A. Now all A will be pushed. Now when input is B, and top of the stack is A, we keep on pushing B. Okay, we push B A, and when B is the input, top of the stack is B, we push B B. So all A and all B will be pushed. Now when input is C and top of the stack is B, we pop B and reach at state Q1. When input is C, top of the stack is B, we pop B. Now all B's and C's will be over. Okay, now when D is the input and top of the stack is A, we pop A, we reach at state Q2. When D will be the input, top of the stack is A, we keep on popping A. Now all A and D will also be over, all B or C over. Now finally input is epsilon, top of the stack is Z node, we keep Z node as it is and we will reach at the state QF. We will reach at the state QF. So this is the language acceptance by final state. Okay, so this is the required PDA corresponding to the given language, that A raised to power n, that number of A equal to number of D, and number of in between there is number of B equal to number of C. So this is the final required PDA corresponding to the language. Thank you.